Right, hi everybody, and we're going to start to look at the further mechanics part of the A-level course now, the first bit being circular motion. Before we get into the motion part of it, we're just going to look at some basic circle geometry. A lot of this will be very familiar to you from lower down the school anyway, but just to recap some of the things. So the first thing through, quite simply, well, what do we mean by a circle? Circle, in physics terms, being the path, so I'm going to use Thomas as an example, being the path that any object would take if it's following a curved path and remains a set distance from a particular point, that being the centre of the circle. So as Thomas moves around, he's always the same distance away from the centre of that circle, therefore his path is defined as being circular. Okay, now with that, there's some key features of a circle that I'm sure you'll be familiar with, but we'll go through anyway. I'm going to draw some lines in freehand here. Okay, so we've got one line that goes from one edge through the centre to the other edge, and the length of that line is known as the diameter of the circle. Okay. And we could draw another line that just went from the centre of the circle to a point on the edge. I'm going to go straight up for that one. Okay, and that line, the length of that line specifically, is the radius of the circle. So that won't be unusual to you at all. And of course, the radius is exactly half the diameter. Diameter runs straight through the centre, the radius just from the centre to the edge. So the radius, half the diameter. Quite often in questions, they'll give you the diameter of the circle, where a lot of the equations use the radius, and they'll try and trip you up to see if you can remember to convert to a radius first before you do any calculations. Other key parts of the circle is the distance from around the circle between 2 points. So I'm going to call this point O and this point P. And if we just darken that bit in the darker green, that distance around the edge of the circle is called an arc length. And if that was to continue all the way round the circle, that distance would of course be called the circumference of the circle. Now, one of the special things about circles is the relationship that there exists between the circumference of the circle and the diameter. And for every circle, there is a set ratio, and it's a constant of nature, and it won't come as any surprise to you what it is. Okay, so if you, for any circle, were to take the circumference and divide it by the diameter of the circle, you get that magic number pi, which of course is 3.14 to 3 significant figures. Okay, and if we want that in terms of radius instead, well, because radius is half the diameter, then you simply end up with 2 pi being the circumference divided by the radius, which gives you circumference equal to 2 pi r. Nice and easy, nothing overly challenging or different for you there. Now, if we were looking at linear geometry instead, we'd quite often be looking at the position of a point around the circle, and we would be considering x, y, z coordinates, and that's if it's in 3D, the z coordinate, and if it was moving at the same time, we'd also be considering a time component with that as well. Okay. For a circle, you can do that. You don't usually worry about the Z component because a circle by definition is a 2D shape, but it's usually easier to talk about it in terms of what we call polar coordinates, which use a distance from a set point, as in the centre of the circle, i.e. the radius, and the angle from that. So we take the original position, a nice simple measuring position, that's why I've drawn the radius like that, straight up, and we were to measure the angle between that. I'll just use the line I've already got in for diameter for this. Then the angle between the two, theta, would be the other coordinate that would be of interest there. So I can pick any point on this circle. I can define it by knowing the radius of the circle and the angle from a chosen reference position, which would usually be straight up or north, if you like. Okay, now that angle, as I've drawn in, obviously is 90 degrees, but it can be any angle, obviously, up to 360 degrees. So a circle traditionally is split into 360 degrees. Okay, it's a fairly arbitrary man-made decision on the number, largely because it's fairly divisible by quite a few factors. However, it's not the most convenient unit of angle, and we will have to get used, particularly those who don't do A-level maths, will have to get used to using a different measure of angle. Okay, now this measure of angle, which will involve another line going in here, is a special one, and it's defined from the length of the radius and an arc length. Okay, now as I've drawn it now, we've clearly got a radius from the centre of the circle to point O, and we've got an arc length there between O and P. Now that arc length is larger than the radius of that circle. But if we made it so that the arc length was exactly the same as a radius, which I'm going to approximate to be around there, okay, and then in purple I have that particular angle. When the arc length equals the radius, that angle theta is defined as being 1 radian. Okay, so that's an absolutely key bit of information, that instead of working in degrees, most of the time we will be looking at angles of radians for that. Now, as from that definition, okay, so if arc length is equal to the radius, then the angle is 1 radian. Okay, so the arc length of any circle, I will change colours again, is equal to the radius of the circle multiplied by the angle in radians. That's true for any circle as long as that angle is in radians. So the arc length from there to there would be the radius of the circle multiplied by that angle in radians, and we'll discuss what that is in just a second. Now, by definition, if the circumference of the circle is 2 pi r, which we've already got here, okay, that means that the circumference is all the way round, so the arc length is equal to the circumference. R is in both equations, which means by definition there are 2 pi radians in a circle. That's pretty important, okay, because that gives you an idea of the different sizes of these. Now we're just going to finish off, I'll just move Thomas to the top for now. Just going to finish off by having a look at what the conversions are then between radians and degrees. So we've already said that, I'll just do it across here, we've already said that in a full circle there are 2 pi radians and therefore 360 degrees. Therefore, pi radians is 180 degrees. Now that's going to be a useful little conversion measure there, just getting in terms of 1 pi. It works out then that 1 radian is 57.3 degrees, and 1 degree is pi divided by 180 radians. That's essentially a rearrangement from up here. Okay, so being able to do that conversion, if you're given an angle in degrees, which sometimes they will again to try and confuse you, try and trip you up, converting that by taking your angle in degrees and multiplying it by pi divided by 180, that is a key conversion factor you will need to do.